Now I will discuss string matching with finite automata. Now let us consider one example. Here the pattern is given, it is ABABC. Now what we need to do, we need to build one finite automata using the pattern given. We'll consider that initially when no character is matched, we are at state 0. If the first character of the pattern A is matched, then we will move to state 1. If we are at state 1 and the second character of the pattern is matched, that is if the next input is B, then we'll move to state 2. If the third character of the pattern is matched, we'll move to state 3. If fourth character is matched, we'll go to state 4. Now if the fifth and the last character is matched, we'll move to state 5, which is one accepting state. So first, using the pattern given, we need to build one finite automata. We need to take care of all the input symbols. The input alphabet consists of A, B and C. Now if we are at state 0 and A is the input, we will move to state 1. But what will happen if the input is anything other than A? Then we need to also draw these edges that for input B or C will remain at state 0. Similarly, if we are at state 1 and if the next input is B, then we will move to state 2. But if the next input is not B, if the next input is again A, then what will happen? We will remain at state 1 because the first character A of the pattern is matched again. But if the input is neither A nor B, if the input is C, then we are at state 1, that is the first character of the pattern is matched, A is matched. Now the next input is C. So what will happen? We will move to state 0. That means no characters are matched. No characters are matched and we will be at state 0. Then again we need to match the first character of the pattern. So in this way, if at any point of time, if we can reach state 5, in that case it is sure that we have found one match. Then we need to return the position number from where we are getting the matching. One example is given here. Suppose we want to match the pattern ABABC in the text given. Text is here, CAABAA. This is the text. Now how we can do the matching? Character initially we are at state 0, where the next input is C. So if we are at state 0 and the input is C, we will remain at state 0. That is done here. We are at state 0 and the next input is A. So what will happen? We need to see the graph from 0 where the input is A. So we will reach state 1. So here it is written. Now we are at state 1 and the next input is A. So what will happen? We need to see the diagram. We are at state 1 and the input is A. So we will remain at state 1. This is written here. We are at state 1 and the next input is B. So what will happen? We need to see the diagram. We are at state 1 and the next input is B. So we will reach state 2. Here it is written. We are at state 2 and the next input is A. So what will be the state? We are at state 2 and the next input is A. So we will move to state 3. That is written here. We are at state 3 and the next input is A. So what will happen? We are at state 3 and the next input is A. So we will come back to state 1. This is done here. So in this way we can change the current state. After scanning each next character, we will need to update the state. If at any state we can reach the final state, that is accepting state 5, then we can be sure that we have found one match, and we can return the position from where the matching is started. Now what is the advantage? Advantage is that if we can draw the diagram, then for matching it will take scanning of all the n characters, so the complexity will be big O of n, excluding the time needed for drawing the diagram. But the drawback is that if the input alphabet size is high, then the graph will be very complex. Just consider here ABC is the input alphabet, and for that this is the graph. Now if the input alphabet consists of A to Z, all the characters, small letter, capital letter, numeric values, so then the graph will be very complex. So actually this string matching with finite automata is not so useful, because of the problem that we in the diagram will be very complex.